Hi friends, welcome to my channel Mana Lectures. Today we will discuss about some more topics in the real chapter of real numbers. What are they? That are what is prime factorization? What is prime factorization? We need to discuss, and some and LCM. What is LCM and HCF? As you know, what is the meaning of LCM and HCF? LCM is the least common factor, HCF is the highest common factor. There is a small difference between these two, and these are mostly related to each other also in calculation part. And here these two relation is also there is another one factor, there is another one option to find the numbers, what is the given number, and there are different ways to find out these numbers and find out the given number also. First of all, we discuss about what is prime factorization. Here prime factorization simple definition is, as you see, prime factorization is the prime factorization is to write a composite number as a product of its prime factors. It means prime factorization is, as you know, what are the factors and what are the prime numbers. We know individually what are factors and what are prime numbers. Here prime factorization is, we need to represent any number in the form of prime factors of factorization of factors, which is simply, if we explain one example, it will be easily understand to you. If we need to represent any number, suppose we take 72, we need to represent prime factorization. What is prime factorization? We can also understand in this example also. If we take 72 as a number, we need to represent this number as a product of prime factors, prime numbers. Here how can we solve? Here we can solve this method in method is same, but the representation, some of them represent in this way and some of them represent in another way. There is a different ways to represent the numbers of calculation in this prime factorization. I simply represent in this way, and I show another method to represent the number, but the method is same. Here 72, first prime factor is 2. Here we write 36 2s as 72, and then 36 we divide by 2, which is 18, and then 9 times, and then 2 table cannot divide 9 exactly. So, and after 2, what is the prime number? Prime number is 3. Then we check if 9 divided by 3 or not. Yes, 9 divided by 3 on 3 times. So we write this, and then 3 will be divided by 3 on 1 time. It is the method to get the factors of prime numbers of given number, which is composite number or any other number. Here we can represent 72 as factors of, as like 2 into 2 into 2 into 3 into 3 into 1. 1 is not necessary to mention. If we mention also, there is no problem. And then here we can simply call it as 1 2 3. So we can write as 2 power 3 into 3 1 2, and means 3 power 2, and I neglect the 1 in this method, in this representation. Here we can write 72 is equal to 2 power 3 into 3 power 2 as a prime factors, In this way we find the prime factorization of any composite number. This is a method, and we can also represent this method is same and representation is different, as 72 is represented as in this way, 2 36 times. Same here, same method. Here again 2 is represented as 36 is represented as 18. Here same, 2 as 9 times. Here 9 as 3 threes. So we can simply leave 1 threes, and then we write 2 power 1 2 3, which is 72 equal to 2 power 3 into 3 power, here there is no another branch, another set, so we write 3 into 3, which is 3 square. Here in this method also the answer is same, 2 power 3 into 3 power 2, but in this method also 2 power 3 into 3 power 2, which is same. So we find the prime factors in this way, and we see another question, another topic in this video. What is LCM? Here LCM full form is least common factor, which is least common multiplication least common multiple. What is the meaning of LCM? Here simply we call least common multiple as LCM, which is more popular. And here LCM, it is the product of the smallest powers of each common prime factors in the number, which is, it means we represent the composite number or any number in the form of prime factors in the earlier discussion, and from that factors we select the product of smallest powers of each common prime factor in the numbers. Suppose in the previous example we write 72 as a product of 2 power 3 into 3 power 2. We represent if we take another number also, in LCM is defined for any two numbers or two or more numbers. If we take 18 or 18 as another number, then we simply solve 3 times. So 18 we can write as a 2 into 3 power 2, which is 2 power 1 into 3 power 1. Here LCM is, here the LCM of 72 and 18 is, we can say, least smallest power of each common prime factor. Here these are the prime factors, smallest power in both common. Here 2 is common in both 72 and 18, so we select least number, which is 2 power 1 and not 2 power 3. Here it is 2 is common, then we select the least number in powers. 3 is greater than 1, so we select a smaller one, which is 2 power 1, into, and then 3 is common in 72 and 18, we select which is least, but here 2 is power also same, then we select 3 power 2. Here the answer is 2 into 3 square is 9, 9 2s are 18. Here 18 itself is the least common factor in these numbers 72 and 18. But in HCF, in another one is HCF. Here HCF is the another one. Then HCF is different, somewhat different. HCF is the highest common factor. Means product of the greatest power of each prime factor in the number. You understand what is the difference in this example. Here I am taking the same question, same examples, 17 and 18. 72 equal to 2 power 2 into 3 power 2, sorry, exactly same or not, 2 power 3 into 3 power 2, but 18 is equal to 2 into 3 square. Here in HCF of 72 comma 18 is the product of greatest powers of each prime factor, means same number. Here 2 is the same as well as in the LCM, but we select highest means greatest means highest number in both common, 2 power 3 into Here 2 is equal in both cases, so we select 3 power 2. But if it is 3 in this case, we select 3 power 3. If in LCM case, if there is a 3 and 2, we select 3 power 2 as a LCM. So here, then here the HCF of 72 and 18 is 2 power 3 into 3 power 2, which is 2 power 3 is 2 2s are 4, 4 2s are 8 into 3 into 3 9, 8 9s 72. Here the HCF of 72 and 18 is 72, but the LCM of 72 and 18 is 18. In this example, the HCF is 72 and LCM is 18, but in all the conditions, given numbers HCF is the greatest one and the given number the smallest one is the LCM is not defined, is not understanding of our problems in our discussion. Here there is another another example we take in this video, in this solution, in this example taken 18, 12 and 18 as our examples in another one. To find, first of all, to find any prime factors, any LCM or HCF, we need to first calculate the prime factors. Here prime factors are 2 into 6, 2 into 3. These are the prime factors of 12. And 18, for 18, 2 into 9, 9, 3 into 3. Here the prime factors are 12 is equal to 2 square into 3, but for 18, 2 into 3 square. Here the LCM and HCF, the LCM is firstly HCF. The HCF is the, as you know, the highest common powers in the prime factors. Here highest one is 2 power 2, and in 3's highest power is 3 power 2. So 4 into 9, which is 36. HCF is 36, and LCM is least, which is 2 into 3, which is 6. Here 36 is the HCF and 6 is the LCM. Here in this case LCM 12 comma 18, which is not 12 is LCM and 18 is HCF. There is different value for the different numbers. And here one of the other condition we need to discuss, we need to know about that is, if any number is the, if we take any number which is the, it is the product of both LCM and HCF, as simply we can write as, if we take a number x and y, if we take two numbers x and y, sorry, if we take a number x which is the product of HCF and LCM equal to, which is equal to product of HCF and LCM. This is another important condition which is helpful in solving the problems. We need to discuss this in another videos and another problems also. So in this video we will discuss, what we discuss is what is LCM, what is prime factorization, what is HCF. LCM and HCF, to find we need prime factorization. LCM and HCF are most frequently used things in our mathematics. So we see what are the different problems asked in our exercise 1.2 in next video. Until then, please subscribe to my channel and Thanks for watching the video and please subscribe to my channel Mana Lectures.